when you're playing the game. So right here I can move around freely just by right-clicking and moving my mouse. But here it would be based on whatever control scheme I'm using. That would control the camera for this. So game view, scene view. Down here is the project window. The project, so the hierarchy is everything that's in your scene. And Unity has this notion of game objects. Everything in your scene is a game object. This camera is a game object. This directional light is a game object. And these game objects all have components attached to them. So anything that's in your project, which right now is completely empty, will be here. But stuff that's in your project view is not necessarily in your scene. It's just everything that's available to you to build something. Console is where there's just output from error messages or debug messages. Very useful for figuring out what's wrong with your code. And then over here we have the inspector. So when you click on an object, you'll see information about this gives you information about the game object and all the components that are attached to it. And so I can kind of collapse these components here. So this camera, every game object has a transform attached to it. The transform is just the position, rotation, scale of that object. That's required on every game object. Even if it's a game object that's not even rendered, you don't even look at it. It still has a position somewhere in space. So you can kind of think of it as an imaginary point, movable point in space. So what we want to do is we want to do this Unity shooter tutorial. So if you go to the site, so Unity has a series of tutorials, and you can actually download all the assets. This has all the art, all the music, all the meshes, everything you need to actually complete the project. And then it has a series of videos here that you can watch. They'll take you step by step. And the videos are not that long. They're only like 15 minutes top. So you can do 2 steps a night and be done with one of these in a week or so. So the first thing we want to do is download the assets for this project. Now I could have clicked on that link, but we can also look at it inside the asset store here. So this is the asset store, which is this asset store tab. Any one of these tabs can be accessed via this window menu. So if you accidentally close something, then you can go here to bring it back up. So what we want to do is we want to go and we want to look for the space shooter tutorial. And we're going to download the assets for it. So I'm here, and it tells me it's free. It's not something I have to pay for. There's a lot of free assets on the asset store to get you started on whatever game you're trying to make. And I'm going to click on import. Now it gives me this warning saying that I'm importing a complete project. Some assets are just meshes, just music, just textures. Others are complete projects that include project settings. And so this is just telling me that if you import this, it could override your project settings. So be very careful when you import an asset that is a complete project, because if you set up a bunch of layers and tags, it'll override all that stuff. This is a brand new project though, so we're not concerned, so I'm just going to import. Preparing the package. It gives me a list of stuff here that's going to get imported. So we'll say import. And it's chugging through all those assets. It's indexing all this stuff, so it's very easy to find in the Unity editor. Okay. So now my project has all this stuff. We've got models, materials, audio, and we even have a completed assets. So this completed assets actually has the completed game. That way you can kind of compare to what you're making with what it should look like in the end. So the very first thing we want to do is we want to set up our project. So the Space Shooter tutorial is set in a almost for like a mobile game. Very simple design to it. And so the first thing we want to do is give ourselves a kind of a mobile aspect. So right now our game view is a free aspect camera. So our resolution just depends on how big this window is. But we actually want to use, just because this project is set up that way, we're actually going to add our own custom resolution of 600 by 960, which is kind of your standard portrait scape of mobile phone. We'll call this mobile. So here you can see that I can choose between different aspect ratios in the game view. So now we're on mobile, so now we have kind of a mobile portrait viewer screen. We can actually move this a little bit. There's a little bit more room here. Okay. So the very first thing we want to do is add our spaceship to the game. So this kind of gives you a view. This is kind of just a top-down basic shooter where everything is coming at you, scrolling towards you, and you're just shooting things as they come through. Kind of, almost like old school asteroids. So the very first thing we want to do is actually add our player object. So here we can see the various models that we have, and you can even see a preview of these. If I can, I don't have my slider here. That's weird. Did they get rid of that in 5.2?
Slider for what?
To actually see the preview of what these things look like.
I think it's.
Is it in that gear menu off to the right hand side? Guess not.
No,
You can change it to the 2-column view. That should work too.
Okay, there we go. So now we can I can click on models here and get it'll show you a preview of the models you have available. So when you click on this, you'll see down here that it says Vehicle Player Ship FBX. So this is, an FBX file is a 3D object file. So you would make this in something like Maya or Blender. And the FBX file contains not just the mesh itself, but contains the textures, as well as it can contain animations. So there's a lot of stuff that can be put in that FBX file. And you can kind of expand it out, and it will show you various properties here. So really, all we have here is just the mesh. So I'm going to drag this to the scene, and it's as simple as just dragging it to the hierarchy. Actually, let me get rid of, we're going to start without the directional light or the camera. So here's my ship. It went ahead and added the materials for it, which is, so if you look over here, there's two components. So we have our transform that tells us where our ship is. Now we want to put our ship at 0, 0, 0 just because it's kind of nice to start at the origin, and it makes calculations from like left to right much easier. And there's two components here. We have a mesh filter, which just contains the data for our mesh. That's all it does. It's just the skeleton data. And then what actually renders it is the mesh renderer. And so the mesh renderer has a series of materials, which you can see here, that tell it how it should actually look on the screen. So here you can actually see the material of this. So I can actually click on the material, and you can see it's the various textures that are assigned to materials. I don't want to go too deep into materials, but just think of it as for a given mesh, a material can have multiple textures assigned to it, and then that mesh you can actually assign multiple materials to it. So where a texture can be like the base color of it. You can also have textures that have normal information, like the normals of the mesh itself, height maps, occlusion maps. There's all different types of textures. And you put all of those inside a material, and then the shader will create a wood effect or a glass effect on your mesh. So we've got our player here. We're gonna add some controls to them here in a bit. The next thing we need to do is actually add.
Actually, I have a question.
Yeah.
How would you make? Because I know you personally explained it to me before, but how would you make like the design of these textures by hand?
Just an art program, Photoshop. So you design the mesh in a 3D tool, Blender. You can actually even just draw and design the textures there. And but you can design. So it actually, the mesh actually has UV coordinates. So it unwraps this kind of UV textures, and you draw onto those whatever it is you want to actually show on it.
Right. So they like purposely made this this texture to wrap around that specific object.
Yeah. So some textures like terrain and brick, they're just patterns, and you can add more and more of them to just give you a large brick wall. Other textures are made for specific meshes. So this texture was specifically made for this mesh. It would not look right.
Rather unique.
Yeah, it would not look correct on another type of mesh that doesn't have the same characteristics. So we have our ship here, but first off, we need a camera. So let's go ahead and add our camera. If you don't have a camera, you'll see this area here that no camera is rendering. So we're going to add a camera. So now we get a view into our scene. Problem is we don't actually see our ship. The reason for that is that our camera, which way is our camera pointing? Okay, so our camera is actually pointing kind of with our ship. We want it to actually point down at the ship, so it'd be kind of a top-down game, as a lot of mobile games are. So first thing we want to do is let's zero out everything. You can zero out it, or you can just right-click on the transform, click on reset. What we're going to do is we're going to rotate it on the X direction, or the X-axis, and we're going to rotate it 90 degrees, and then we're going to bring it up. And we'll give it, we'll do 6 units. Actually, no, we need a little bit on that. Yeah, we'll do about 10. Now, so, if we're doing a scrolling shooter, one of the problems here is our ship is in the middle of the camera. We want to keep our ship at 0, 0, 0, just because it's easier to move around left to right. So what we're going to do is we're going to move our camera up a little bit so that our ship is right at the bottom. There you go. So right there. So if you hit play, let me maximize here. You hit play, and it will show you the current state of the game. Not much to go with, not much there.
So when you move the camera, you just grabbed one of the axes?
Yeah, just grab it and slide it. So I want to get rid of this background color. And actually what I want to do is I want to get rid of all the current lighting that's in there. So I don't have any actual lights in my hierarchy, but there is an ambient light that is in the scene that you can add. You can just have ambient light that just comes from all directions. But we want to go and get rid of that. So there's actually a window called lighting. I'm going to find it here. And this has a lot of information about, so we have our skybox, which we don't need. We're just going to get rid of that because we're going to actually add our own type of background. And then the ambient color, we're going to drop that down to essentially black. Now, you notice that the ambient color is black, but the background still appears blue. That's because our camera will actually have its own background color. When there's nothing else to render, it will render this background color. So let's go ahead and set that to black. Now, as you probably noticed, we can't see anything anymore. So this is where we're actually going to add a couple lights to illuminate our scene. We've gotten rid of all the ambient light. And in this tutorial, so I'm doing this in the same kind of steps that the tutorial does. That way you can, when you look at the videos later, it'll be kind of fresh in your head. So in this tutorial, they actually use 3 directional lights. A main light, a fill light, and what they call rim light. So the main light is used to denote where the main source of light is, which is where the sun is, wherever the ship is orbiting. The fill light is essentially just a counterpart to the main light that is a dull light that just kind of illuminates the rest of the part so that you don't have just one side of the ship lit up. So let me go ahead and add a main light just so you can see this. So we're going to go ahead, we're going to go to Game Object, Light, and go to Directional Light. So a directional light is a type of light that is supposed to simulate a very far off light in the distance. And so you can think of it as coming from all directions, well not all directions, but coming from everywhere in a single direction. So the position of this light doesn't really matter. So if I move this light around, you notice that it doesn't change anything. It's the rotation of this light. So the position of this light doesn't matter because it's meant to simulate a far away light. Only the rotation matters. So for this main light, what we're going to do, actually let me go ahead and reset it. So we're going to have it kind of off to the side and a little bit downwards. So you can kind of see, actually a little bit more so you can kind of see the, there we go. So now we can tell that there's a light over here somewhere. And if you're making a very realistic space game, this would probably be all you'd have. Because if you think about it, you know, it's almost like the dark side of the moon. It's all black. You don't see anything. But for the sake of a video game, that might not be the case. You might actually want to see more details. You know, realism does not necessarily mean playability. So, I'm going to go and add another directional light. So this is our main light. And I'm going to go ahead and add another directional light. And actually what we're going to do is I'm going to duplicate this light by hitting Control-D to duplicate an object. This will be our fill light. And this light is going to be kind of a counterpart to our main light. So, we're going to swing it around almost as if it were on the opposite side. Let's see, let's click on both of these so we get a good idea. Actually, I'm going to disable my player ship just so I can see those lights a little bit better. The gizmos form. Let's just slide there. Zero space out. Add our player push it back in. So there's our main light. This is our fill light. We're going to reduce the intensity of this. So because right now it looks like the light's coming from both directions. It's illuminating both sides of the ship. So what we're going to do is we're going to decrease the intensity just a little bit so we can still have that notion of the main light is off to our right. And then we're going to give this a nice little kind of a little bit of a hue to it. Okay, so now we have a main light here, and we have a fill light. That's just making sure that this doesn't appear completely black on the side. It's kind of hard to tell on, I guess you can tell a little bit on the screen. So a third light that they use in the tutorial is what's called a rim light. And the rim light is used to accentuate the edges of the mesh. So I'm going to take the fill light, duplicate it. And for this, we're going to have it point upwards, just so we can kind of see the almost like the back part of the engine. And then we're going to actually let me reset this just to make it easier. So that's if it was up top, but we're going to have it kind of come from the bottom. And this is our rim light. It's mostly so we can see the back part of the engine. Let's see if we actually. Switch it back to white. And let's increase the intensity a little bit. So it might be really hard to tell from the projector. So that's with the rim light, so you can kind of clearly see the back part of the ship. At least I can on my laptop. I don't know if you can on that projector. But if I remove the, oops, if I remove this light, the back part of the engine actually, we lose a little bit of the detail of the back. So the rim light is really just to kind of accentuate the edges. So now we have a little player object. We have our lighting set up. Now it would be nice if we actually had a background. So fortunately, they include a background with this. Let's see if I can find it. Oh, one thing I forgot to add is I want to add the jet stream to the back of this, the engine trail. So under Prefabs, there's actually some special effects, and you can take this engine prefab, and we're going to add it to our player ship. So if we look at this prefab, so the difference between a prefab and a game object is, so your game objects exist in your scene. You can take those and turn them into prefabs and put them in your project folder. That way, so let's say you build this complex object in your scene out of game objects. Let's say you're building this right here. And you've got a podium game object, and a laptop, and a mouse, and some other stuff that they're all kind of built together. Now, what if we want to build that, we want to duplicate that in another scene? Well, we'd have to go and rebuild all that stuff. So what you can do is you can actually take any game object, I'll take the ship for example, and drag it into your project folder, and that creates a prefab out of it. So now I can create a new scene and then add that prefab to that scene without having to recreate everything exactly like it was. Now, you notice when I delete the prefab, it says you can't undo this action because I'm actually deleting this out of my project. So be very careful when you delete prefabs. So, this engine are these flares. So these are actually called particle systems. And so this is just kind of a particle system that's going to be used for the engine flare. Now, if you notice on our scene view, the engine flares is the wrong way. It's not aligned perfectly with the ship, but in our game view, it looks fine. This is because these particle flecks are actually using what's called billboarding. Billboarding causes the particles to always face the camera. So here, our scene view camera is seeing these. We'll see these particles just like this, but the camera in this view still the particle system is actually rotating itself to always face the camera. And if I move this around, you can kind of get an idea of billboarding. So if I look up, you see how it's always facing me. No matter which way I look at these particle effects, they're always facing me.
It's basically like the 2D textures you'd see from like classic N64 games.
Yeah, and so it works out here because it's just going to be top down, so we're not going to rotate the camera anywhere, and so that's fine. So now let's get to actually adding a background image. So what I'm going to do is I'm going to create what's called a quad.
On this one part,
Yeah.
How did you position it relative to the ship? It's right at the back, but I didn't know
Yeah,
that.
so it kind of handled it on its own, so it conveniently, actually no, it is kind of a little bit off. So I need to move that back just a little bit, right there. So you can move it around, just like you would any other object. When I added it to the player ship, it kind of conveniently matched up fairly well. It looked like I just had to tweak it just a little bit. And we can hit play just to kind of see it. So it looks decent. Okay. So what I'm going to do, let's clean up some stuff here. What I'm going to do is I'm going to create a game object, an empty one. So I don't want to create it there. Make sure it's reset. And we'll call this lights, and we're just going to put all our lights under that game object. So the hierarchy has this parenting, so we can parent objects to other objects. It's really nice for complex, complex objects like human beings. You can kind of have a hierarchy for their whole skeletal system, so that when one part of it moves the rest of the system with it. Okay, so I'm going to create a background. What I'm going to do is I'm going to create what's called a quad. Quad is just a plane, essentially. And where's our quad? Let's reset it to 0. So our quad is pointing the wrong direction. So let's rotate it to, looks like 90 degrees. Make sure that's all 0. And what we're going to do is we're going to add our background texture to this. Let's see, I think it's under texture. Yeah, so here's our tile nebula texture. So we can see that this is 1,000 by 2,000. So vertical, basically a vertical picture. We're not going to change any of the information on the texture itself. Unity automatically imports textures. For this, it's just the background color, but if it was some type of special texture, you may have to modify some of the settings here. But what we're doing is fine. So there's two ways you can do this. I can add this to the quad, like so. And what this does is it actually creates a, oh no, this one actually found the material for this. But if it couldn't find a material, it would create a material for you. So, so we have our quad here. Let's rename this to background. And what we want to do is we want to go ahead and scale this up to the rest of this, to fill up the rest of this area. If it goes past where the camera is, that's fine. If it bleeds out, because it's just a background image. Now, before I go further, one thing I forgot to do. Our camera right now is in perspective mode. This is for like first-person view games, and kind of how we see it realistically. But for a top-down game, especially like a scrolling game, we probably want to change the view to orthographic, because perspective tends to warp the sides of your screen. So there's two projection modes, perspective and orthographic. Orthographic, if you ever make any type of 2D game, you're most likely going to be using orthographic. The main difference is that in orthographic mode, things that are further away, so in perspective mode, things that are further away appear smaller. In orthographic mode, that's not the case. So, I'm looking at that door over there, and from my perspective, that door is about this tall. But that's not, in reality, that's not how tall it is. In orthographic mode, my view of that door, everything essentially flattens out. And it's good for 2D games. That way I can move a door behind a character. The character will always appear in front of it, but the door won't get smaller. It'll stay the same size. So we're going to change the orthographic. It's not going to make much of a difference here. Now let's adjust the position of our camera. Fix that. And let's take our quad. And we're going to scale this outwards. And we're going to actually move this up a little bit. Whoops, not rotate it. Just want to move it. Not that either. So, this texture, when we looked at the texture, what was it here? The original, we want to keep the same aspect ratio, 1024 by 2048. So it's a 1:2 aspect ratio. We want to keep that same ratio because we don't want to distort the image. So I'm going to make this, the width is going to be 6.5. That looks like it covers everything. And then, so our Y value for the height will be twice that, so that'll be 13. So now you can see this image. Now, you notice it's clipping through our player. So what we're going to do is we're going to move that background image down, just like that. So you notice that the background image doesn't get smaller. That's because we're in orthographic mode. If we were in perspective mode, it would get smaller. So this lets us move the background downward or behind the player without actually having to distort its size. Now there's another problem here in that our background is very dark. Actually, all of our lights are kind of dark. Let me see if I can increase a little bit of the main light here. Yeah, it's a little bit better light on that side. Let's do a little bit more room light too. There we go. It's a little bit better. Now, so our background should actually be a little bit brighter than this. The reason it's kind of dim is because it's actually using the directional lights to light up that plane. But we don't really want to have that realistic lighting on it. We'd actually like it to just kind of appear without any additional lighting, just by itself, what's called like self-lit or unlit. And there's a special shader material that does that for us. So in our material here, remember, material has one or more textures, actually 0 or more textures, but generally you'll have 1 or more textures in the material that make up that material, and then that material gets added to a mesh. So this uses the standard shader, which makes all the lighting affect that object. And for normal objects, that's what you'd want. However, for this background, we actually don't want it to be lit up by the lights in the scene. We'd actually like it to just appear unlit. Oops, that's not what I wanted. Unlit texture. So now you can see that the details of the background pop out more because they're not relying on any external lighting. It's just using, oh my searches keep popping up. It's just using this unlit shader that doesn't take into account any lighting in the scene. So it's a nice way to be able to create a background image but not have our lighting affect it. There are other ways to do this, but for this purpose, this is the easiest way. You can also use layers, but that's a bit more complicated.
That also saves on performance as well, because
Yeah.
it's not calculating all the lights in the scene.
Yeah, calculating all where all these lights are going does take up a fair amount of processing power. So if you have unlit objects, like backgrounds that don't need to be realistically lit up, then change them to an unlit shader. So now we click on play, and we have our little ship there, but we're not doing anything yet. So this is where we get into scripting. To actually add movement to the ship, we're going to have to read input controls and then react accordingly. So Unity uses C# and JavaScript as its main programming languages. I prefer to use C# just because I studied Java. Java and C# are very, very similar to each other. So if you know Java, if you studied it, then C# is the way to go. Even if you do web development with JavaScript, the JavaScript in Unity is a little bit different. It's called Unity script. It's very similar to JavaScript, but not quite. It's almost like JavaScript with class support. So we're just going to use C# here. So what we're going to do is we're going to go ahead and we're going to make something to actually move our player ship around. Now, one thing we need to do is add a unit of physics to our player ship. And this is called a rigid body. So I can go here to add component, click on rigid body, and this will let me specify the mass of the object, how much drag it receives from the air drag, whether it's affected by gravity. So this is our unit of physics that we can place on an object. Without a rigid body, our object essentially has 0 mass. It doesn't even have the notion of mass attached to it. So to have that concept of mass, we have to add a rigid body to it. Now, that's not the only thing we need, though. We also need what's called a collider. So this rigid body is telling us some physics information, mostly mass and air drag, and whether they're affected by gravity, which, since we're in a space game, we actually don't want to be affected by gravity. However, it doesn't tell us any information about the volume of the rigid body itself. It's just telling us the mass. So what we're going to do is we're going to add a collider. And we'll use a capsule collider. So this is, colliders are these kind of standard shapes that are used for collisions, and they're generally used in conjunction with rigid bodies, but they also have other purposes too. So a capsule is essentially just two circles that one of them denotes they're just on different axes. So, and then you can specify a radius for each one. Now, so if let's like reduce the radius of the size here, increase the height. Now, if you notice, it's increasing it on the wrong axis. It's going up and down, but we actually want the capsule to be laid on its side so that we can see it from the top down. So what we'll do is we'll change the direction to the z-axis. And so we're going to kind of form this capsule around this guy. The capsule will be used to detect hits on the ship itself. So we want it to be pretty snug fit. And that's about good right there. Yeah, that looks pretty good. So, you need a rigid body, that's your unit of physics. You need a collider, because that's going to deal with the collisions. So, there are two different systems actually. You have a collision detection system, and then you have a physics engine. The physics engine relies on the collision detection engine to tell it that, hey, you've run into something. Now calculate the physics and what happens after that collision.
And the rigid body is associated with the ship.
Yes. So these are all components. Everything in Unity is a component that you put onto a game object. So now, let's actually add a component to move the ship around. So this is going to be a script. So we click on New Script, and we'll call this Player Controller. And the language is C#. We'll do Create and Add. And then I'm going to double click on this script, and then we're going to edit it. So if you've never done any programming, this will look very foreign to you. Unity, so this is C#. So Unity actually, every component that can be placed on a game object, every script, needs to extend mono behavior. If it doesn't extend mono behavior, then you will not be allowed to put it. If you try to put it on a game object, it just won't work. Mono behavior is going to give you a couple methods here that allow you to start gets called when the game object is first created, and then update gets called once per frame. So every frame, it's calling update. So what we want to do is we're going to change the velocity of our ship depending on what buttons we're pushing. So the first thing we need to do is actually get a reference to a rigid body. So I'm just going to create a reference to a rigid body here. And inside our start method, we're going to assign that. So we want to get the component that's on our game object. It's as simple as calling a function called getComponent. And then we tell it the type of the object that we want, the type of component. So before we can use a rigid body, we have to assign to something. So getComponent is going to look at the game object and look for a component that matches that type of rigid body. Now, so update is where we're actually going to change look for input and change the velocity. Now, in the demo, they actually use a different method called fixed update. Update occurs once per frame. The problem with that is that we're not guaranteed 60 frames per second. our frame rates can change at any given moment. So if let's say we were getting 60 frames per second and we calculate the velocity once per second, but then all of a sudden we get 30 frames per second and we're only changing the velocity every 2 seconds. And so the amount of time that's gone by has increased. So we have to take that into account when we change our velocity. Because if we don't, then depending on the frame rates, our chip will move faster or slower. One way around this, though, is just to use fixed update. Fixed update is guaranteed to happen at set intervals. Not once per frame, but every like 0.01 seconds or 0.1 seconds. There's a standard amount of time that goes by. So we're going to use fixed update. So what we want to do is we're going to there's a special object called input. The input object is where all input comes from. You don't have to create it, you can just call it. You can just say, hey, give me the state of this button. Give me the state of movement in this direction. And the input manager helps you organize all this. If you go to edit, you go to project settings, and go to input, you can see all the defined axes. The fire 1 button, fire 2 button, horizontal, vertical. We can see that this is mapped to A and D, and the vertical is mapped to S and W. So WSAD keys for that. And you can change all this here. But all we have to do is we have to reference these by their names, horizontal and vertical. So let's do that. So we're going to get the value. All these, when we get the axis, the vertical or horizontal axis, it's going to return us a value between -1 and 1. So if we're hitting backwards, we'll have -1. If we're going forwards, it's going to return +1. So that's float value. So we say, we'll say vertical equals input, just input with capital I, get axis, and we're going to give it that name, vertical. That has to match up with what's defined here. If it's misspelled, it's going to generate an error.
This is all case sensitive, right?
It's case sensitive, yes. Second thing we want to get is the horizontal movement.
You put one more R.
Thank you. Horizontal. Make sure I spelled it right. Okay, cool. So this is going to get us a value between -1 and 1 for each of these. If I'm pressing W, it's going to return 1. If I'm pressing S, it's going to return -1. Same with left and right. So remember, the rigid body is our unit of physics. So we're going to change, all we have to do is change the velocity of our rigid body. Now, there's additional methods for moving rigid bodies. You could add force to a rigid body, but for our purposes, we're just going to change the base velocity of it. So all we have to do is say rigid body velocity equals, and velocity is a vector here. A vector is a three-dimensional vector is 3 values, and it's just used to represent a point in space. We can also use it for things like velocity, because velocity is not just speed. Speed is a scalar value. It's a single value. I'm going 50 miles an hour, I'm going 10 miles an hour, I'm going 60 miles an hour, and so on. Velocity is my speed and direction. I'm going 60 miles an hour northwest, going 50 miles an hour southeast. So that is in the case of a compass, it would just be a 2D vector. But here we're actually in 3D space, so it would be a 3D vector. So we're going to create a vector object. So let's call this new vector 3. And then we're going to give it the values of x, y, and z here. Now, so let's look at how our ship is oriented. So its z value is forward, the x value you can kind of see up here is left and right, and the y value is up and down. Now, we don't want to move toward and away from the camera. That has no effect. That wouldn't help us at all. So y is always going to be 0 here. X is left and right. That's our horizontal. So put that here. And then z is our vertical. So every fixed update, it's going to grab the state of our axes, and this is going to depend on if we're hitting a button. If we're not hitting a button, it's just going to be 0, no change. And then we're going to set that as our rigid body's velocity. So if we're not pressing anything, the velocity is going to be 0. And if we're pressing something, the velocity is going to be a value between -1 and 1. So let's go back here and let's hit play. If there's ever any compile errors, you'll see them in the console here. So now I can actually move my guy around. The camera's a little too close. There's not much to move around. And I'm moving fairly slow. I might want to move a lot faster than that. So first thing I want to do is let me orthographic, we'd actually change the sizing here. I'll change this to 5.5. So a bit more room. And then let's increase the size of our background. We'll go to 7 and 14. That's because there's a little bit more room. Our ship is a little bit big. Now, we're only moving, our velocity is only going from -1 to 1. But what if we want to go faster than that? Well, all we have to do is just multiply that by a speed value. So let's say the speed value is something that we want to modify ourselves. We want to tweak. So I'm going to say public float speed, and I'm going to initially set it to 0. Actually, no, we don't need to do that. Now, the reason I made this public is because anything that's public will show up in the inspector. That way, we can modify the value of speed inside the editor without having to recompile our code. Now, so I'm going to take speed, and I'm going to multiply it. I'm going to multiply each one of these axes by speed. Like so. So now, after this is compiling, you can see now I have a speed rating here. So let's try a speed of 4. So it's going to multiply all of our inputs by 4. So now you can see that I can actually move around quite a bit faster. And that feels pretty good, actually. Now, if you notice one thing, it lets me move past the camera. And that's not something we want.
Probably create like invisible walls.
There are multiple ways to do this. You could create a collider around your area so that when you hit it, you don't move. But we can also just clamp the value. So what we're going to say is we're going to give it a x minimum, x maximum, z minimum, z maximum. We can't go any further than those minimums or maximums. So public float x min, x max, y min, actually not y, z min, z max. And now here, we're actually going to, I'm thinking how to do this. Oh yeah. They use the clamp function. How do they work this on velocity? So we give it the value and then the minimum and the maximum that it can be.
Wouldn't that need to be on the position, not on the velocity?
Yeah, it would need to be on the position itself. So we're going to set the velocity. But we need to get the position first. So we'll get the position. Whoops. Actually, what I'm going to do is down here, we're going to get the position. Now, so what we can do is game object, when you say game object with a lowercase g, it's referring to the game object that script's attached to. And we're going to get the transform and then the position. And so what we want to do is we want to clamp the position down. So we're going to let the velocity do its thing. But if our position goes beyond our area, then we want to clamp it by that. So, we'll say clamped x equals, so there's a library called mathf, which has a lot of different functions that you can use. And we'll say clamp, give it the value of position x, and we'll say x, the minimum value can be x min, and the maximum value can be x max. So the position won't change unless it goes beyond x max or goes below x min. We'll do the same thing for clamped y. I hope I'm remembering this correctly. If not, we can always just bring up the video.
Yeah, wouldn't it be, actually no.
I think you can also clamp it from the rigid body component itself as well.
So we could say rigid body.
I think in the inspector,
Oh, really?
yeah, there was a clamp movement, I believe.
There's constraints.
Constraints, yes.
But that
Yeah, so
only
those-
freezes the position.
Yeah, that just
that
freezes.
just freezes.
Yeah.
Never mind.
Let's try to do this. Let's try to say position equals new vector 3 clamped x 0 z.
You'd have to rename your float to Z.
So let's see if this works. So we'll set x min. So we're at 0, 0 right now. So x min will say -5, x max 5. Actually, let's do 10. Z max will say -10 and then 10. Let's just see if we did this correctly. Oh, apparently not. Well, now we don't really know because we made,
Those values might be out.
yeah.
Try going to 5.
No, it's going way beyond the clamp value.
Can you move it to the edge of the screen and then find out where it is?
Yeah, what I'm going to do though is, let's just play the video.
It should have the code below it.
Yeah, actually, yeah, I'm just going to look at the code sheet. So what they do is they do velocity equals movement times speed,
Oh, they did it in the position.
and then they say the rigid body position, and then they clamp the position with their boundary. Let's just steal their code. well, most of their code. So we set the velocity, and then we're going to set the position, and we don't primarily prefer to, we'll just use X and X. I feel like this is exactly what we did, though. Oh, I guess it was using the rigid body positioning. Okay, let's see if this worked correctly. We still have our mins and max set up. Oh, okay, that is working actually. Now we just need to modify our values here. So let's go 4, 4, 4, and 4. Actually, yeah, we'll just look at the value here, 2.8. And I'll assume that over here is negative, around negative 2.8. So for the x value, we'll do negative 2.8, and then 2.8. So there we go, we're clamped right there. And then let's say, Z min, we'll keep that at 0. And let's see what Z max is. Whoops.
Can't go any further.
Z max is not enough. Let's increase that. The good thing about having public variables is we can actually increase these during gameplay. Now, it's not going to save our values. It's going to reset back. But we can get a good idea that this is going to be about 8. We'll do 8.
You can also copy your component there.
Yeah,
if you hit the gear, and then save it when you exit play mode.
Start building. That will be 8. Oops. And we're actually going to keep the Z min. We'll just say negative 1, because we don't want to go back that far. There we go. So now we're kind of clamped into this field area. Won't let us go out of it. So just look at that code again. So we get the vertical and horizontal inputs. It's going to be a value from -1 to 1. That's a normalized value. So we're going to multiply that by our speed to give us what our velocity is set at. So we set our velocity, and then we set the rigid body's position so that we clamp it to our minimums and maximums. So if we go beyond the minimum, it will clamp that value. And that keeps us constrained within that area. Now, something else you'll see in the code here is they actually added a little bit of rotation. So when you move from the side, it'll tilt that way and tilt the other way. And so what they do here, now quaternions is a very complex data structure used to model rotations. There's a lot of complex math that goes into it, but they're very nice to use in terms of rotating objects. Now here, and there's a lot of different functions we can call from the quaternion. So right here, what it's saying is we're gonna tilt. So we have a tilt factor. What we're going to do is we're going to get our velocity in the x direction. So moving left and moving right. Depending on what that velocity is, we're going to tilt a certain amount. So we're going to use what's called Euler angles, however you want to pronounce it. We're only moving in that x direction though. We're not moving, we don't care about the rotation. We're not rotating, in the z or x or in the z or y or anything like that. Just based on the velocity in the x direction. Now the tilt factor, so this is x, y, and z in terms of axes. So if we look, what we want to tilt, remember the z-axis is pointing forward. So the z-axis is what we're actually going to rotate around. So if we were rotating around the y-axis, we'd be doing yaw like this. Rotating around, or actually no, that would be yaw. So rotating around the z-axis is our roll factor, or tilt, as we're going to call it. And we can specify, so that number gets multiplied by the negative tilt. The reason we use negative tilt is because we have to factor in the fact that when we're moving left and right, if we just multiply it by the positive value, we'd actually tilt the wrong way. So whenever you see something like that, usually just multiply it by -1 to get the opposite effect. So the coding part of this may seem pretty intense initially, especially if you haven't done any coding before. But it's just really something that you got to practice with. When I first started doing Unity, and even now, I'm constantly just Googling things. How to do this, how to do that, how to create a flickering torch in Unity. And there's a great community. You'll Google that, and you'll find the exact answer. Somebody will post some code there, and you can take that, kind of modify it, and play with it.
Does tilt have to be defined somewhere?
Yeah, so we're gonna tell it how much we want to tilt. Our tilt factor. And that pops up here. Let's try a value of 5. Let's see what we get there. Maybe a little bit more. Let's go with 7. Let's just go with 8. So now we're tilting from side to side. So now we're really getting to kind of a very simple but somewhat interesting game. So the last thing we're going to do here is we're actually going to shoot a particle. We're going to shoot something out the end of this object. Now, so first thing we want to do is we're going to build our bullet, build our actual particle that's shot. So again, what I'm going to do is I'm going to create a quad. It's going to hold our bullet. Let's rotate this guy. Actually, what I'm going to do is I'm going to create an empty game object to hold it. We'll call this our bullet. We're going to put our quad under that. That way we can rotate the quad without rotating the bullet. Yeah, there we go. So 0, 0, 0. And then we're going to rotate it so that it's facing up. Put that to 90 degrees. And now what we want to do is we want to look for, we have a couple textures here. We'll use the this kind of bright image here. And we'll just throw that over the quad. Let's remove our player shape for now so we can see it. So we see it here. It looks dull, and I don't know if you can notice it, but the black area is actually, we've got essentially a bullet inside of a black box. We don't want that black border to show up. So there's a special shader to do this as well. There's a shader that will take the color and the intensity and just add it to the background. So black is 0, 0, 0. No addition there. While white is 256, 256, 256, and that will essentially drown out whatever's in the background. And that is called a additive particle shader. So we're going to go down here to, let's click on our quad. So right now, again, it's using the standard shader. That's kind of the default shader that gets added to everything. But we're going to change this to a, let's see, particles, additive. So now that black box disappears. And all we have is our particle, and our particle looks a bit more lit up. because it's actually adding into the background. So we're going to take this. I'm going to cheat again just because.
Are lights having an effect on that?
On the additive particles, do you know the lights affect the additive particle shader?
I believe so.
Okay. I mean, we can test that.
We can open it up.
Is there a way you could add a light to the quad and like add like a sort of a lens flare effect to it, to its rigid?
You can add lens flares. They're only affected by directional lights, though. I think. I don't know if point lights will affect a lens flare. I think that's.
No, that's on the camera, I believe.
It doesn't look like this is affected by the light. So I'm changing the light values, but it doesn't seem to have much of an effect at all. So I'm going to
Is
say
that the directional light?
Yeah.
Point lights might affect it.
Say what?
Point lights?
Oh, point lights? Okay.
Maybe. But you can add a light to the particle itself if you wanted to shine off of other objects.
Okay, and so what we're going to do here, again, we're going to give this bullet a unit of physics. We're going to add a rigid body. Now for this one, we probably also want to go ahead and add a collider. Just do a capsule collider, just like we did last time. I'm going to put the capsule collider on the z-axis, and we're going to reduce the height and radius so it kind of matches up with our particle bullet. There we go. Whoop. There we go. Now, now we want our bullet to essentially go forward. This is really easy to do, actually. So we're going to add a script. We'll call this our bullet script. We can do edit script. So when the bullet gets first created, we're going to change its velocity to move forward. Now, moving forward is always moving in the positive z-axis. So my forward vector is always z going forward. Now, there's a difference between my local coordinates and world coordinates. So the world axis, the z might be pointing that way. But on my local coordinates, my local system, my z-axis is always facing in front of me. So even if I'm rotated this way, my z-axis is always pointing forward. This makes it very easy for me to just tell something to move forward. I can say, move in your positive z direction. Go for it. So, I'm just going to grab the code here. So you see that they have a speed value, so we can change how, we can modify how fast that bullet goes. And then just in the start method, we're going to change its velocity. We don't need to change the velocity every frame. We change the velocity once. That changes the velocity of that rigid body. Every frame, it's going to have that same velocity and move forward.
Where does it get its initial position?
The initial position will be defined by us when we actually shoot the bullet. We're going to say spawn at this position, and then it's going to handle firing off. Let's say rigid body. So what this does right here is this gets the transform's forward vector in world space and multiplies it by speed. So let's go back to our program. Go back to Unity. Let's give this a speed. Let's try 15. We're gonna hit play, and there it goes. Non-convex mesh collider. I don't have a mesh collider on here, do I? Oh, we do. Let's get rid of that. Then just like, get rid of that one too. So now we have our bullet that gets fired, just like so. What we're going to do is we're going to turn this into a prefab. That way we can instantiate it during play. So we're just going to grab the bullet, and I'm just going to put everything in the main folder. We're going to grab the bullet, drag it to here, and then it creates a prefab out of it. That has everything that's in here. You can click on it, and you can see the quad. And it even has the bullet script and everything. So now we can delete this out of our scene. Let's put our player ship back. And so what we want to do is, and this is the last thing we're going to do for this this demo, is when we hold the button down, we want to fire these projectiles, a single stream. And we want to be able to control the rate of fire. And so to do that, and again, I'm cheating. We're going to modify, so this is the player controller script. We're going to do some modifications to it. So the first thing we need to do is we need to know what prefab we want to create and where we want to create that prefab at. So what I'm going to do is here, I'm going to create an empty game object, and I'm going to call this shot point, or shot spawn. This is where my shots are going to spawn at. And so obviously we don't want them to spawn in the middle of the ship, just right in front of the ship. So we'll put it right there. And now we need to modify, we need to add a couple things to our player controller. So first off, we're going to need our shot spawn location. It's just our transform. The transform is this, that would be a reference to that object's position in space. And then we also want our bullet itself. And we have to reference this by a game object. So these are both public. That means they'll show up in the inspector, and I can actually drag and drop the prefab and the shot spawn into it. So shot spawn, I'm going to take this, put it right, oops, put that right there. And I'm going to take my bullet prefab and put that in the bullet prefab slot. And so now what we're going to do is whenever we press down, we're going to instantiate a bullet right at that shot spawn. And I'm going to do some cheating. So we're going to use a value called next fire to control our rate of fire. And let's see. So we're not going to do it. We're not going to fire another shot until next fire amount of seconds have gone by. So, oh, we also need a fire rate. Sorry, the fire rate is what's going to control. That's what we're going to be able to set. So the first thing we're going to do is say, okay, the next time we can fire equals our current time plus our fire rate. So actually, well, first let me just copy this so I can show this to you in the code itself. We don't need the rest of that. So we're going to do this inside the update function, not inside a fixed update. So what we're going to do is we're going to say, okay, get the state of the fire one button, which is set up in our input manager as our left mouse button click. And we want to make sure that the current time is greater than the next fire time. So whenever we fire, we're going to say next fire equals our current time plus fire rate. So it's going to make sure that a certain amount of time has gone by before we fire off another projectile. We don't want to fire it off every single frame. I mean, we could. That'd be an incredibly incredibly fast gun. But we want to, be able to control our fire rate. So we're only going to do this if we're pressing down the fire button and enough time has gone by. Then we're going to update our next shot to make sure that some amount of time goes by. And then we're going to call instantiate. Instantiate takes a prefab and creates a game object out of it. We already have, and what we're saying is, okay, create this prefab at this location with this rotation. And so I just need to update that to be my bullet. So now we're going to go back here. And I'm going to set the fire rate. We'll do 0.5 seconds. And let's see if this works. There we go. And it's a little slow. Let's do 0.25 seconds. And actually the bullet's kind of slow too. I'm going to make the bullet a little bit faster. We can change it right here on the prefab. There we go. It's a little bit better. So now I'm holding down the button and it's shooting those particles as we end. Now, there's one little thing that's happening here that you don't see, and that is we're spawning tons of bullets. We never actually despawn these bullets.
They're just flying.
And they're just flying out, and they'll stay there until something destroys them. So there's multiple ways to destroy bullets. One thing, you can have a script on there that just says, after 5 seconds, destroy the bullet. Or after 10 seconds, destroy the bullet. There are things called pool managers that keep they help you recycle all these objects, because instantiating and destroying game objects is actually very expensive. And so if we can avoid having to do that, if we can just disable it and then re-enable it, we can get a lot better frame rates. Now for this game, there's not that much going on, but for other games, we have a lot of stuff going on that can severely slow down your system. So usually you use a pool manager to kind of handle all that for you. But now we've gone through part 1 of setting all this up. And we have our boundary too. We actually kind of went into part 2 a little bit. So what I think we'll do is maybe next month we'll do part 2 and then do part 3 after that. Or you can just do it at home because all this stuff's available. And I definitely encourage you to do part 1 again. For me, the second time I look at something, the more it exponentially makes more sense rather than the first time I hear it. But so we have very basic controls, and we have what can be the start of a very simple mobile game. Any questions?
I'm still a little the spawn point.
Oh, so
How does that follow the ship? Is that
so the spawn point is a child object of the player ship. All the children move with the parent, and that's what's happening there. So here I can show you. See how it's moving with the parent? If it wasn't a child object, then we'd have to update that along with the parent. But any children will move with their parents. They'll rotate with their parents too. So I could have a staff that has 3 orbs that rotate the top. It's a magical staff. And then when I move the staff, those orbs will stay in their kind of local positions. I won't have to update those orbs as well. They move along with the staff. So it just kind of helps you, especially when you're building complex objects. You can have a parent game object, just move the parent, and the entire car with its wheels and doors and everything, all the little pieces that make up with it, that make it up, will move along with it. You don't have to tell each individual piece to move. Any other questions? Yes.
Can you show the animation for the fire?
Oh,
The
the engine fire?
yeah.
Okay, so yeah, that's not an animation. That's actually a particle system. So particle system, this is the particle system here. And so a particle system shoots off particles at a given rate, at a given burst, and you can modify all these different things about the particles.
Now you can have animated particles,
Yeah,
and
Yeah.
that might have a texture sheet on it.
yeah, you can have animated particles. Let's look at it. Doesn't have a texture sheet animation, just a material. So each one of these particles can be a mesh, it can be a flat image, it can be an animated image. You can even tie the particle system into the animator and then create a keyframe animation out of it. So just to give you kind of a quick example, so I'm going to save this real quick. And just to create a very simple particle system. So generally particle systems are used for fire, smoke, sparks, all the kind of various magical effects you see. So if you just go to Game Object and go to Create Particle System, it'll create a very generic one, and so you can kind of see it here. You can specify how long the particles last. So let's say right now they last 5 seconds, but I want to be a random value between 1 and 5. So now you can see some of the particles actually don't live as long as the other ones. Same with start speed. We can change the start speed so that some of the particles have very slow speed and some of them have a very fast speed. So here you can kind of see how it changes. And there's all different types of stuff here. We can change the shape to be a sphere. So now these particles are just coming off this thing. Kind of looks like a radiation or something. We can also change it to where it's not a constant rate. We can say, what if we just want to do bursts? So we want to do a burst at time 0 and a burst at 2 seconds later. So now it's burst 1, burst 2.
That's insane,
That's
how much it's doing for so little work on your part.
Here we can actually change it. Let's say we want to make it a cube. Let's change the material to, so now we're spawning a bunch of cubes. All I can is particles. The particles can even bounce off of things. We can create let's create a cube, a floor for these things to bounce off of. Oh. We're going to make this thing a red color. Or we're going to change the material on just so we can. No, that's fine. And our particle system, let's move it up a little bit. Let's say we want it to collide with the world. And now they actually collide with the floor, or most of them collide with the floor. So yeah, you can do all types of stuff with particle systems. Yesterday I actually did that for my class, of showing smoke effects, fire effects, how you use sparks. So they're really cool, these particle systems, and used very frequently in games.
So ballpark, how many particles do you have at once before it really starts to show?
This laptop, let's see. So we'll do we'll just do a standard rate of 500, and we'll say maximum amount of particles is 10,000, and things still look good. Yeah, this is running on a laptop.
Actually, not that many faces on each of those cubes.
But they all
You
have
had a complex object that you were trying to.
A complex object, and I mean these are meshes though. Generally particle systems, you're not going to be spawning meshes. You're going to be spawning flat images.
You could try putting the spaceship in that.
Let's try that. See what happens.
We
really just want to crash.
Yeah. Here we can do asteroids. Whoa! Oh, our computer just decided to turn off.
That wasn't because of the fuse, that was because of the battery, I'm sure.
Yeah. So my laptop pretty much said no.
If you can make like the old rooms with dirt slide.
Actually, what's funny is that there's a game where when you
Yeah, you can do like force over time, so as particles explode, but then get swept away. There's so much stuff you can do with particle systems. Like for class, we barely scratched the surface. You can have like smoke effects. Normally, like let's say you have a jet flame, and so it'll generate smoke out the end of it, and you can have the particle expand based on speed. So initially, when it's coming out very fast, the particle is very small, but as they slow down, the smoke kind of expands, and so you can have the particle basically. You have a texture, a smoke texture, and then it would expand out, and maybe even fade away after a while. It's one of those things where there's so many different things you can do. It's something that you really want to play around with and just try out different things. Best thing to do would be like, say, look up a tutorial on how to make a fire with a particle system, and how to do smoke with a particle system. And then you could start.
We could do particles next month.
We could. I think we haven't really done much with particle systems, so I think that might be a good thing to do. So, that's it. We will do more of these. We do them every month, and we'll probably do a part 2, part 3, just to kind of finish up this tutorial. Please take all the food. There's so much food there. Yeah. We are, like I said, we do this every month. We also meet up and just kind of work on our own projects and help each other out every now and then. We do game jams every now and then. We also have just set up 2 VR laboratories. So we have a VR co-work space on Union, and you can actually get access to that by becoming. We have a Patreon campaign. And so we're using that to basically you can become a member and have access to that space, be able to use the VR equipment and do some VR, make some VR games, whatever. We also are setting up a VR laboratory here in FIT, which will be cleaned out if I have some volunteers over here on Saturday. And that'll be more for research. The Institute of Intelligent Systems will have access to it, and but yeah, we're have a lot of cool stuff going on. So we're happy to be able to kind of help develop this local community of game developers. I'll put Memphis on the map. There's no other questions though. That's it.
Thank you very much.